Let me start revising, my dear students, that we have studied yesterday the Arrhenius concept, and according to the Arrhenius concept, the acids are the or yesterday we have started with the electrolytes. So we have seen that we have various types of electrolytes like acids, bases, and salts. Acids and base react with each other to produce salts, and we have various types of acids and bases like strong acids and strong bases, and salts can be acidic, basic, or neutral. Uh, Strong bases, when it reacts with weak uh, acid, it will give basic salt. Strong acid, when it reacts with weak base, it gives acidic salt. And strong acid and strong base, or weak acid and weak base, when they react with each other, they gives us the neutral salt. And that is why the process of acid and base reacts with each other is known as the neutralization. And when acid and base reacts with each other, they gives us salt and water. This particular reaction is known as the neutralization reaction. Then we have seen that the ionic crystals, when they are added into the water, these ionic crystals, they produces the ions, and these ions are surrounded by the water molecules. You can see that here we have a sodium atom which is surrounded by the water molecules. Here we have Cl minus ion surrounded by water molecules. Here we have sodium plus ion surrounded by water molecules. Here we have Cl minus ion surrounded by water molecules. This process of the surrounding these ions by water molecule is known as the hydration. And then, my dear students, we have seen that these waters are stabilized by this hydration energy or hydrations. These ions are stabilized into the solution by the hydration energy, and these water surround these water molecules surrounds the ions, and that is what it makes the water to be the ions to be more stable into the solution. Water has got very high dielectric constant, so this attraction or attractive force between ions, which is known as the electrostatic force of ion, electrostatic force of attraction between the ions in ionic compound is inversely proportional to the dielectric constant. Water has got its dielectric constant almost 80, and that is why the when anything is being added to water, its force of attraction is reduces by the factor of 80, and thus the substance can be easily dissolved in water, and that is why water is called an universal solvent, because almost all the things in a smaller or larger quantity they dissolve in water. Now we need to study about the Arrhenius concept of acids and base. Arrhenius says that those substances which produce H plus ions in aqueous solution are called acid. Those substances which produces OH minus ions in aqueous solution are called base. And then Arrhenius has explained that water can react with H plus ion produced by itself and produce H3O plus ion, which are known as the hydronium ion. This hydronium ion can also make the hydrogen bonding among themselves, or among hydronium ions makes hydrogen bonding with the water molecules, and thus it can form H5O2 plus, H7O3 plus, or H9O4 plus, and this is how we understand the formation of the various ions into the water. Same way, OH minus ion which are produced, they also form the hydrogen bond with the water molecules and produces H3O2 minus ion, H5O3 minus ion, and H7O4 minus ions. Limitations of the Arrhenius concept, my dear students, that Arrhenius cannot explain the ability of ammonia to behave like base, because ammonia does not have OH present in it, but still ammonia behaves like base. Thus, the concept of Arrhenius was limited up to the aqueous solution only. Then the new scientist came. His name was, or then the new scientist work came into the existence. They were the Laurie and Bronsted, and they collectively explained that those substances which are acid, they produces, or they are the proton donors. Proton is nothing but your hydrogen ion H plus, and those substances which are base, they are proton acceptors. So those substances which accept proton, they are bases, and those substances which donate protons, they are acids. When we look into the water, we will find that when it reacts with ammonia, water donates H plus and turns out to be OH minus. So here water behaves as an acid. Same way, my dear students, when our water reacts with the HCl, when water reacts with HCl, my dear students, let me explain this. When water reacts with HCl, it accepts H plus ions. That is what we can understand. That when water reacts with HCl, see, if we have HCl and then H2O, it produces H3O plus ion and Cl minus. And that is why when this HCl is crystallized at certain temperature and pressure, then you can see that H3O plus Cl minus ions present into the crystal of HCl, and that is how the presence of H plus or H3O plus has been confirmed. So this is how the Laurie and Bronsted gave the idea of conjugate acid and conjugate base. The substance, when from the substance, if we remove H plus, the species that is produced, which is known as the conjugate base, and to the substance, if we add H plus, and the species produced is known as the conjugate acid. So you can see that OH minus is the conjugate base of H2O, and H2O is the conjugate acid of OH minus. NH4 plus is the conjugate base of ammonia, and ammonia is the conjugate base of NH4 plus. You can see here from H2O, when we add a proton, we get H3O plus. So H3O plus is the conjugate acid for water, but OH minus is the conjugate base for water, and this is how we can understand that water is an amphoteric substance. Please remember, my dear students, that a strong acid has a weak conjugate base and a weak acid has a strong conjugate base. A strong base has a weak conjugate acid and a weak base has a strong conjugate acid. Conjugate acid has one extra proton. Please remember that when we compare two species, so we come to know that conjugate acid has got some extra proton, and conjugate base will have one H plus less as compared to the species with which we have been comparing. You can see that water behaves as a base when it reacts with HCl, and water behaves as a acid when it reacts with ammonia. So when water behaves as an acid, H plus is lost and OH minus is produced, but when water behaves as a base, it accepts proton and turns out to be H3O plus. So now, my dear students, you might have come to know that we have the pair of acid and base, which are known as the conjugate acid and conjugate base. From a species, conjugate acid can be produced from any species. If you want to produce conjugate acid, we just need to add H plus to it. And from any conjugate species, if you want to get conjugate base, we just need to remove H plus from it. My dear students, if the species is neutral, then you make a conjugate acid or conjugate base, then the charges will be produced. Or if the species is even charged, then if you get conjugate base, the charge is increased by -1. And if you get conjugate acid, then the charge is increased by +1. So please remember that when you get a conjugate acid or conjugate base, there is a possibility that mostly the charges also changes when we get conjugate acid or conjugate base. You can see that HF has conjugate base F minus, H2SO4 has conjugate base HSO4 minus, HCO3 minus 1 has conjugate base CO3 minus 2. Now we have the next question, conjugate acid for the following Bronsted. So we need to find out the conjugate acid, my dear students. To get the conjugate acid, we just need to add H plus. So if we have Bronsted base and if we add proton H plus to it, we will get conjugate acid. So if we have NH2 minus and if we add H plus, then this positive and negative charge will become neutral and we get neutral NH3. When you have NH3 and if you add H plus, so the charges is increased by +1. So each time when you make conjugate acid, the charge is being increased by +1. So here if charge is -1, then you add +1 and it becomes 0. So you get neutral species. Here there is 0 charge. If you add +1, it gives +1 charge species. So NH4 +1. Here you can see that the species has got -1 charge. You add +1 and ultimately the charge becomes 0. So if we have HCOO minus, we add H plus, so we get HCOH, which is known as the methanoic acid or formic acid. So this is how by addition of the proton we can get conjugate acid, and by the removal of proton we can get conjugate base. When we get the conjugate base, my dear students, the charge is decreased by -1. Each time when we make the conjugate base, the charge is decreased by -1. So this neutral species turn out to be -1. This neutral species even turns out to be -1, but this -1 species turn out to be -2. So this is how we can understand the the conversion of Bronsted acid and Bronsted base from a species. So now, my dear students, if we have these species and we can prepare or we can get the conjugate acid and conjugate base both for such species. So if we have water, we can have H3O plus as a conjugate acid and OH minus as a conjugate base. So when we add H plus to water, we get H3O plus, which is conjugate acid. When we remove H plus, we get OH minus, which is conjugate base. Same way for HCO3 minus, if we add H plus, we get neutral H2CO3, and if we remove H plus, then the charge is being increased by -1, and we get CO3 minus. Same way when we have HSO4 minus, if we remove H plus, we will get SO4 minus 2, and if we add H plus, we will get neutral H2SO4. Now if we have neutral species NH3, when we add H plus, the charge become +1 and we get NH4 plus. And if we have neutral species and if we remove H plus, then the charge is decreased by -1 and we get NH2 minus. So this is how, my dear students, we can truly understand about this various species that we can look into. I hope, my dear students, you are able to understand. बच्चों ये समझ में आ रहा है? कुछ डाउट है तो पूछ लो. देखो एक बार फिर से समझ लो. If you have neutral species, then its conjugate base will have -1 charge and conjugate acid will have +1 charge. But if you have -1 species, then your acid will be neutral and your base will be -2. If you have +1 species, then your acid will be neutral and your base will have, sorry, your base will be neutral and your acid will be +2. The acid will be +2 and base will be neutral. So when you turns out any species into the base, then it goes like you can add -1 to it, and if you turn out any species to an acid, then you can add a +1 to it. So this is how we can get the conjugate acid base pair very easily. Please note that H2O, HCO3 minus, HSO4 minus, NH3 can act both as a Bronsted acid as well as Bronsted base. So there are many species which can behave as an acid as well as base at the same time. Then we have the next question, my dear students. Find the conjugate acid base for the following species. First, if we have NO2 minus, we want to get conjugate base or conjugate acid. Now we can see that there is H available. So that H we can remove. So by removal of my H plus, this neutral species turns out to be -1 and we get NO2 -1. But if we add H plus, what we may get? We may get H2 NO2 plus. Okay, so this is how we can do it. Same way, if we have Cn minus, then if we add it H plus to it, we can get HCN. If we have HCl4, if we remove the H plus, we can get ClO4 minus. If we have F minus, we add H plus, we get HF. If we have OH minus, and then if we remove H plus, then we can get O minus 2. Please remember that when we go left side, we will add -1. And if we go right side, we will add +1. So my dear students, you can see that F -1 turns out to be HF, but OH -1 turns out to be O minus 2. And OH minus, when we go right side, that means acid side, we get neutral species. Same way, my dear students, you have CO3 minus 2. So if we add H plus, it turns out to be HCO3 minus 1. So this -2 plus 1 has become -1 and we get HCO3 minus. And when we have S minus 2, we add H plus, we will get HS minus. You can see that -2, when we add +1, H plus 1, that turns out to be -1 and we have HS minus. So this is how it is easy for you now to understand how to write the conjugate acid or conjugate base pair. Let us revise the same question. What would be the conjugate base for the Bronsted acid HF? If we add, if we remove H plus, we want to get conjugate base, so we'll have to remove H plus and the charges will be -1 added. So HF turns out to be F minus, HSO4 turns out to be HSO4 minus, HCO3 -1 to turn out to be CO3 -2. Same way, if we want to get conjugate acid, we will have to add H plus. So the charge will be added +1. You can see that NH2 -1 plus 1, that gives NH3. NH3 minus will turns out to be NH4 +1, and HCOO minus will turns out to be HCOOH. And this is how we can find out the conjugate acid base pair. My dear students, I hope till now you must have understood the concept well. Now we have the new concept for acid and base. This is what it is known as the Lewis acid and base concepts. So we have studied first the Arrhenius concept, then we have studied about the Laurie and Bronsted concept. Now we want to study about the concept which is known as the Lewis acid base concept, and let us study it well. G. N. Lewis defined that acids are the species that accept electron pair. Please remember that now Lewis has said that acids are those substances which accept electron pair, and bases are those species that donates electron pair. So those species that can donate electron pair are bases, those species that can accept electron pair are acids. There is not much difference in Lewis base and Bronsted base. But many Lewis acids do not have proton. Please remember that there is not much difference into the Lewis base and Bronsted base, but there are many Lewis acids available which do not have H. In Lewis base concept, we have seen that acid is a substance which must have H with it, so that H can be donated and behaves like acid. But many Lewis acids do not have H plus. That is what we will understand by the example. For example, if we have electron deficient species like BeCl2, where B has got only 4 electron in its valence shell, if you draw the Lewis dot structure, BF2 again has got 4 electron, BF3 has got 6 electron, AlCl3 also got 6 electron. If you draw the Lewis dot structure, FeCl3 also has got 6 electron if you draw the Lewis dot structure. ZnCl2 will have 2 electrons or 4 electrons in its Lewis dot structure. So this is how these are the species. When you draw their Lewis dot structures, they do not have enough electron in the central metal ion, or this central metal atom is electron deficient, and thus these are the electron deficient species. Once again, my dear students, I'm adding them: BeCl2, BF2, BF3, AlCl3, FeCl2, ZnCl2. We can even add B2H6, which is known as boron hydride, or we can say it is as BH3 twice. So this is also an electron deficient species, and they do not have proton, but they are all Lewis acid. So these are all species which are actually electron deficient, and that is why they behave like Lewis acid. All the cations, my dear students, CO plus 3, Mg plus 2, Na plus 1, H plus 1 are Lewis acids. Same way, my dear students, we can even see all anions like OH minus, Cl minus, F minus are also Lewis bases. So my dear students, we can easily understand about all the cations and all the anions. So all the cations behaves like Lewis acid because they are electron deficient, and all the anions which are electron rich, please remember they are electron rich, and as they are electron rich, they behave like Lewis base. So now we understand it by one of the example. Classify the following species into Lewis acids and Lewis base. So my dear students, when we classify the species into the Lewis acid and Lewis base, we find out that the Lewis acid or Lewis base can be further classified into the ions and electron deficient species in case of the Lewis acids, and we can classify Lewis base as ions and electron rich species. Please remember that Lewis acids can be electron deficient species, and Lewis base are the electron rich species. So among all the species, if we look at, you can see this is negative ion, so it is going to be Lewis base. This is negative ion, so it is going to be Lewis base. This is positive ion, which is going to be Lewis acid. This is electron deficient species, so it is going to be Lewis acid. H2O behaves as both Lewis acid as well as Lewis base because it has BF3 is actually an electron deficient species, and NH4 plus is a positive ion. So my dear students, you can see that ions like H plus, NH4 plus, they are cations. So they are Lewis acid. Electron deficient species like BCl3, BF3 and H2O. So they are electron deficient species and they are Lewis acids. Same way, if you look into the ions, we can see OH minus ion and F minus ion are the Lewis bases. And we can see that electron rich species is water that we have. So please remember, my dear students, that H2O acts as a both Lewis acid as well as Lewis base. And this is how, my dear students, we understand the concept of Lewis acid and Lewis base. Still, if you are not able to understand the Lewis acid base concept, please ask me if you have any doubt. बच्चों अगर कुछ समझ में नहीं आ रहा है तो पूछ लीजिए. Okay, then let's move forward. We have a new question that we need to explain. Strong acids have weak conjugate base and weak acids have strong conjugate base. Why and how? Let us understand it, my dear students. So for an acid, suppose we have an acid Ha. So for an acid Ha, acid dissociation equilibrium we can write. So when an acid is added to water, it donates H plus and it turns out to be H3O plus and A minus. So here you can see that is an acid and it has got A minus as a conjugate base. Here we have water as a base and it has got conjugate acid H3O plus. So this is how we understand the conjugate acid base pair for this acid and water. HA when dissociate forms conjugate acid H3O plus. Consider two acids HA and H3O plus. Now we need to study about these two acids HA and H3O plus. Which among them is a stronger proton donor? Which among these two, which is a stronger proton donor? You have seen that HA has donated H2O plus and produced the H3O plus ions. And that is why we can say that HA is a stronger acid as compared to H3O plus, and that is why H3O plus is comparatively weak acid as compared to the HA. If HA is stronger proton donor, HA will donate protons and not H3O plus. So solution or equilibrium mixture will be containing mostly the A minus ion and H plus. So if you have HA which is a strong acid, if your HA is a strong acid, my dear students, this equilibrium will shift towards the products, and at equilibrium we will have the major concentration of H3O plus and A minus. Now suppose this HA is a weak acid, then the equilibrium should have to shift towards the left side, and thus at equilibrium we will have the major concentration of the reactants, that is HA and H2O. So my dear students, it is very easy to understand that if HA is strong, then H3O has to be weaker. If HA is weak, then H3O plus has to be stronger than HA. It is also interesting to note that A minus is a weak base, so it does not strongly accept H plus from H3O plus, because if HA is strong acid, we have H3O plus and A minus mainly present at equilibrium. So A minus is a weaker base than water. Please remember, my dear students. Now if you look into this, now let us say HA is a strong acid. So when HA is a strong acid, the equilibrium shift towards the products, and at equilibrium mostly you have the concentration of H3O plus and A minus. So at equilibrium the major concentration of H3O plus and A minus has been obtained. That means A minus cannot accept H3O plus easily cannot accept H plus from H3O plus, and that is why A minus remains into the solution and the reverse reaction does not take place. That means A minus is weaker base than water because water can easily accept H plus from Ha, and that is why it is a stronger base. So whenever we have a base and if we get the uh, and that is why we can say that Ha, which has produced the conjugate base A minus, this A minus which is produced from Ha is weaker base than water. So when we compare the basicity of A minus with water, we come to know that water is a stronger base than A minus. Same way, my dear students, when we compare the acidity of Ha and H3O plus, we come to know that Ha is a stronger base. Sorry, Ha is a stronger acid, and that is why it easily donates its protons, and that is why at equilibrium we have the major concentration of H3O plus. So this is how we can easily understand that if an acid is stronger acid, then it will produce the weaker acid than its, and the base also produced from it will be weaker base as compared to the water. So if we understand the conjugate acid base pair, we can see that the acid that we have, which is HF, is a stronger acid, but you can see that the conjugate base that we get is even weaker than the water, and that is why an acid will have its conjugate base which is weaker than water. So strong acid will have weak conjugate base, and weak acid will have strong conjugate base. That is what we can easily understand. So A minus is a weak base if Ha is a strong acid. Suppose Ha is a weak acid as compared to H3O plus, then H3O plus has greater tendency to donate H plus as compared to Ha. Thus, if H3O plus has greater tendency to donate H plus as compared to Ha, H3O plus will donate H plus and the equilibrium will shift towards the reactant side. So H3O plus donate H plus to A minus and make Ha. So reverse reaction takes place, and at equilibrium we have the H2O and Ha available mainly in the equilibrium mixture. So now if we think about two bases H2O and A minus has a more tendency to accept H plus more than water, or else H2O would have accept H plus from the Ha, and we would not have mainly H2O and Ha as equilibrium. So my dear students, if Ha is weak acid, A minus is strong base than water. So if Ha is weak acid, its conjugate base A minus will be a stronger base than water, and that is why it will shift the equilibrium towards the reactant sides, and at equilibrium we will have the most products, like at equilibrium we will have mostly the products Ha and H2O at equilibrium. So this is how we can say that what can we say? Let us read. Strong acid like HClO4, HCl, HBr, HI, HNO3, H2SO4 will give conjugate base ClO4 minus, Cl minus, Br minus, I minus, NO3 minus. Please remember that they are the conjugate base of these strong acids HSO4 minus, which are weaker base than water. So you can easily now understand that all these bases like ClO4 minus, Cl minus, Br minus, I minus, NO3 minus, HSO4 minus, they are bases because they are negative ion and they are electron rich, but they are weak base than water. Same way, my dear students, if you look into the weak acids like HNO2, HF, CS3, COOH, give conjugate base NO2 minus, F minus, CS3, COO minus, and which are stronger base than water. So these are the bases like NO2 minus, F minus, and CS3, COO minus. They are stronger base than water. And that is why we can say that a weak acid will have a strong conjugate base, and a strong acid will have weak conjugate base. Or we can say that a weak base will have strong conjugate acid and a strong base will have weak conjugate acid. Though hydrochloric acid HCl and acetic acid CH3COOH, both of them are polar covalent molecules, but HCl ionizes completely into water. Therefore, Cl minus ion is a weaker base than water, and CH3COOH only or partially ionizes in the water, and that is why CH3COO minus ion is a stronger base than water. So please remember, my dear students, why some acid behave like strong acid and some acid behave like weak acid. So some acid which behaves like a strong acid because their conjugate bases are actually uh, weak bases than water. So when it comes to HCl, if we add it into the water, my dear students, we get Cl minus and H3O plus. Now please remember that Cl minus is weaker than this Cl minus is weaker base than water. So what happens? Cl minus cannot accept H plus from H3O plus, and that is why at equilibrium we will have the major concentration of H3O plus and Cl minus. And that is why we can say HCl is a strong acid. But if you look at the CH3COOH, my dear students, and if you add it to water, it will produce CH3COO minus and H3O plus. But here you can see that CH3COO minus is a strong base, and that is why it accepts the H plus from H3O plus and make the equilibrium to shift towards the reactant side, and that is why this CH3COOH mainly remains undissociated into the water, and that is why it is a weak acid. So this is how, my dear students, we can understand that a very important reason, if you are asked into the exam, please explain it in this manner, that if you have HCl and CH3COOH, if you have HCl, if you have CH3COOH, remember both these are the covalent molecules, but HCl and both are polar even, but HCl dissociate almost completely in water, whereas CH3COOH partially dissociate in water. It dissociate partially. Why does it dissociate partially? Because the base produced from CH3COOH, which is CH3COO minus, is a strong base, and that is why it can strong base than water, and that is why it can accept the H plus from H3O plus and make the equilibrium to shift towards the reactant side. But HCl produces Cl minus ion. Cl minus ion is a weak base, and that weak base cannot accept the proton from H3O plus easily, and that is why the equilibrium mainly shift towards the right hand side, that is the product side, and that is why HCl is a strong acid and it dissociate almost completely into the water. But CH3COOH is a weak acid, and that is why it mostly dissociate, or it dissociate partially into the water. So this is how we can understand that why weak acid are the substances that dissociate partially into the water, and strong acids are the substances which dissociate completely into the water. Tomorrow, my dear students, we will study about the difference between ionization and dissociation. We will study about the short note on indicators. So we will study about indicators, my dear students, and then we will
Yes, sir.
start studying about the uh, concept of pH scale tomorrow. So, and we will solve some of the problems, or we may start studying about the ionic product, and we will solve some of the problems related to them. We will study about the ionic product, and we will study about the acidity,